So people keep asking me like why I have a big giant bottle of olive oil on my desk. They ask me if I drink it, which would be kind of gross actually. So I thought I would just tell you the reason why I have olive oil on my desk is because I like to eat it in salads. Now actually it's probably almost is like I'm drinking it because I put so much olive oil in my salad, but olive oil is actually good for your heart and good for your cholesterol. So that's why I have lots of olive oil all the time. So and I like the taste too. So you know, now you don't have to wonder anymore. You don't have to ask me why I have the big bottle of olive oil sitting around. It's in my salads, which you can see my salad here. It's got tons of olive oil in it. Usually when I get done, I could take the bowl and go like that, you know, like you do with cereal. But anyhow, I like olive oil. So that has nothing to do with the next thing we're going to do here. We're going to talk about identities and equations that have no solution. So sometimes when you have variables on both sides of the equation, you will get a situation where the equation is always true no matter what the variable is. Or you may have another situation where you can never get the equation to be true no matter what the variable is. So how are we going to recognize those two situations? Well, it's really pretty simple. All you're going to do is you just try to solve it normally, and I'll show you what happens. So I look at this equation and I see a grouping symbol, so I'm going to distribute. So I get 12x minus 15 on one side, and on the other side I have negative 15, and negative 3 times negative 4 is positive 12x. And then I say, well, I want to move the 12x over, so I'm going to subtract it, and I do that from both sides. And that cancels, but this also cancels and the variable completely disappears. Now this does not mean that my answer is negative 15. I mean, look at this carefully. It says negative 15 equals negative 15. That's always true. So since you have a statement that's always true, it's called an identity. It means it doesn't matter what x values you put in, this will be true for every x value you can think of. Sometimes you might hear people say there are infinitely many solutions because you can put in any x value you want. So you might hear it described that way also. Okay, the next one here, before I can move things over, I have a 3x and a 5x, and since those are on the same side, I just combine them by adding normally. So I do 5 plus 3 and get 8x. You just add them normally. Okay, and then on the other side I have 8x plus 3. And now I want to subtract 8x to get all the x's together. But again, I notice that things cancel completely out on both sides and the variable disappears. So I get negative 2 equals 3. So because negative 2 can never equal 3 and the variable disappears, that means we have no solution. So basically, you know you're either going to have an identity or an equation with no solution anytime the variable disappears. So if your variable disappears and you know you did everything right, variable disappears, and you know you did everything right, if you get a true statement, you have an identity. And if you get a false statement, that means there's no solution. And again, remember, sometimes people will refer to identity as having infinitely many solutions. So you could have infinitely many solutions, in other words, everything works, or nothing will work. And that happens anytime your variable disappears. So please keep that in mind. And then for the next examples here, we want to label each one either as an identity or no solution, or solve it if possible. So I look at this and I'm going to distribute the negative 2. So I have 6x minus 8 on one side, and I get negative 8, and then negative 2 times negative 3 is positive 6x on the other. And if you subtract 6x from both sides, you end up with negative 8 equals negative 8. Because that's always true, we have an identity. And then over here, I see that I have a negative 12 and a 10, but since they're on the same side, I would combine them before doing anything else. So negative 12 plus 10 is negative 2x, and leave the 5. And think about it, if you try to add negative 12 and 10 and you're not able to do that yet, you really need to go back and review adding negative numbers. At the very least, you should be able to do it with your calculator. You just do negative 12 plus 10 and just remember to add the x when you're done. Okay, now I have a negative 2 on both sides, so I'm going to add 2x to both sides. And those cancel. I get negative 7 equals 5. Since that is never true, that means there's no solution. No matter what I try to plug in for x, I will never get it to work, okay? So here's kind of a summary of everything we've done. First of all, we use the distributive property to get rid of grouping symbols. And then we want to combine like terms if we have to. Well, actually, we want to combine like terms on each side of the equation. And then we want to add or subtract to move all the variables on one side of the equation. That's what step 3 is saying. And then step 4, we want to solve the equation, by adding, subtracting, multiplying, dividing. And then we need to check our solution. Okay? And I didn't have to check these because I found out that they either had always true or never true, so I didn't really need to check those. But if you actually get one solution, you should check it, make sure you did it right. So hopefully you found that helpful, and I will talk to you again soon. I'm going to finish my salad. I'm not going to drink olive oil because that's really disgusting, but I'll probably have quite a bit on my salad. I used to have lots of butter on my popcorn, so I think this is a good healthy step up from having tons of butter on my popcorn. Now I have tons of olive oil in my salad, so that's probably a good thing. So talk to you later.